This lab is NetFlow. So what I'm going to do in this lab is show you how to configure and verify NetFlow. The topology has a router named exporter. I'm going to configure NetFlow on that router. The router is connected to a multi-layer switch, and that's got two host subnets connected. There's also an application server apps, and that's directly connected to the exporter router. I've also got this collector here at 192.168.101, and that's also connected to the exporter. NetFlow starts a cache on the exporter router, and that's where all the application transactions are for any of the conversations between host subnets and switch to the application server. And at a certain time interval, that cache is exported to the collector based on an active timeout setting. This application server's got listening ports for HTTP, Telnet, SSH, DNS, and ICMP. So what I'm going to do is I'm going to generate some traffic from a host subnet as well as a switch. Then I'll show you the NetFlow cache. The exporter router is configured as an NTP master. That'll provide time synchronization for all the devices, since with NetFlow you do have to have accurate time synchronization. Then I'll configure a flow record named Data Center Apps. I'll also configure a flow exporter and exporter apps. I'll also configure a flow monitor named Flow Monitor IPv4, and I'll assign that to gig 03 on the exporter router. Finally, I'll verify the NetFlow configuration. So to start with, I'll go to the export router and show you the NetFlow configuration. Host name is exporter. I've got the time zone configured with a proper offset. Also the summertime PDT recurring. And that's to enable the change between daylight time and standard time. In clock calendar valid, that command enables the hardware clock as a time source for NTP. First thing is flow record. That's data center apps. That's the name. It is case sensitive. That's the application traffic. And this is the traffic that I'm monitoring. I want the QoS. That's a type of service field in the IPv4 packet. I also want the IPv4 protocol. And that protocol is the IP protocol number. That tells the IP packet whether it's an ICMP packet, whether it's EIGRP or OSPF or TCP or UDP. So that's what that is. Then I want the source address, the IP source address, and also the IP destination address. I want to match on the TCP or UDP source port, and also the TCP or UDP destination port. That's the transport option there. Also want to collect counters in bytes, and also collect them in packets. The long keyword means use 64-bit counters instead of 32. Then I've got this flow exporter. This is exporter apps. This is telling the router where to export the cache data. The destination is the collector, and that's 192.168.101. That's this server here, 192.168.101. And it's using source loopback. The NetFlow communication will be sourced from the loopback interface. And the transport will be UDP 900 port. Then I've got the flow monitor. The name is Flow Monitor IPv4. The flow monitor, you have to tell it what the exporter is. So the exporter is exporter apps. That's it there. The cache timeout is inactive 300 and cache timeout active is 300. Typically, the recommendation is to have cache timeout active of only 60 seconds and cache timeout inactive of only 15 seconds. The reason I've set it to a higher value is data will stay in the cache long enough for me to show it to you in the table. Typically, it's a lot less. Reporting tools typically use around 60-second intervals. So you only want 60 seconds of active flow before you export. And the record is data center apps, and that's the flow record. And that's also assigned to the flow monitor. Loopback 0 is the management interface, and that's 192.168.2552. Flow monitors can be applied to gig 03. There it is there. IP address 192.168.3.254, and the flow monitor name, Flow Monitor IPv4, input is the direction. So now for some verifications, I'll just show commands here. So this is the flow record. It's called Data Center Apps. And description is application traffic. Takes up 30 bytes. This is just used to verify that it's correct. So TOS, protocol number, source and destination IP, source and destination transport port, and then the counters. There's also show flow exporter. It's using NetFlow version 9, that's the record format. Destination IP address is 192.168.101. That's the collector there, 192.168.101. And source IP address is 192.168.2552. That's the loopback on the exporter. That'll be the source address. There it shows there, source interface loopback. Transport is UDP, destination port 900, and source port is a dynamic port, 51,144. And that's all there is to that. And then now just the show flow interface. That's on gig 03. So the monitor name is Flow Monitor IPv4. If you do an IPv6, you need a different flow monitor. Direction input and traffic is on, so it's active. It's in the input direction. Next thing I'll do is show you the cache. So I've cleared the cache table. That just does force export, so I just told it to do a manual export. Now, show flow monitor. Show flow monitor name, cache. Okay, and there it is. So right now there's nothing in there because I haven't started any traffic. So you notice the source address is 192.168.3.1, and that's gig 00 of apps. And the destination, it kind of varies here. You got the loopback 192.168.2552, and that's 123. That's NTP traffic. IP port 17 is UDP. 89 is OSPF. And shows you the bytes long and the packets long. So that's just normal networking traffic. And you notice as well there's a multicast for the OSPF. Now I'm going to start generating some traffic. So what I'm going to do here is on host 1, I'm going to generate some HTTP traffic. So how I'm doing that, I'm sending a ping to the loopback of the app server, 192.168.2553. I'm setting the protocol number to 6, and that's TCP. I'm setting the actual destination port as 80, and that's HTTP. And I'm setting a count of 100. So what that's doing is when I do that, it's simulating web traffic. I'll do the same thing on the other host, only this time it's going to be HTTPS. And that's all started there. There's host 1, host 2. So that's all started. Next thing I'll do, I'm going to start an SSH session and a telnet session and do some pings from switch 1. So I'll go to switch 1 here. I'll go SSH. And the reason I'm using a host name is because I want to generate DNS traffic. And there's SSH. I'll also do a show run. Next thing I want to do is telnet. So we'll exit. I'll telnet. now in Telnet, I'll just do a show run. Okay. Now finally, I'll just do a ping to the app server. That'll generate ICMP traffic. So what I'll do is I'll exit now. Now we'll just start a ping to the app server. And I'll repeat it 1,000 times. And use it. And I'm going to use a packet size of 1,000 bytes. And that's working. So host 1 is done. Host 2 is done. And switch 1 is done. That's all the traffic I wanted to do then. The other option is an extended ping. That would be something like just doing ping, then just IP. The target address is apps. Extended commands, yes. Then the source address, don't want to change that. Sweep range, and so 36 to 18024. And sweep interval is 1. It would keep that busy for a while, actually. Now I'm going to look at the NetFlow cache. Now you notice all the flows in the table. So there's 53 is DNS, 80 is HTTP, 443 is HTTPS, and then there's also 22 for SSH, 123 is NTP, and 23 is Telnet. Then you've got the IP source address. So the 53s are just DNS resolution. So it's 192.168.1.1 is the destination. And that's the switch here. And the source is 192.168.255.3. And that's the app server. So there's the conversation there, or the flow as they call it. Then on port 80, I've got 172.16.1.1. And that would be host 1. The 192.168.255.3, that's of course the app server. And 443 is the same thing, 172.16.1.2 to the app server. The source is in the first column, destination is in the second column. In SSH, same thing. SSH is actually the switch this time. So with SSH, the source is 192.168.3.1. That's the gig 00 on the apps. So it's a physical port actually, not a loopback, since it's SSH. Then the destination is 192.168.1.1, and that's the switch. Then Telnet, same thing, 192.168.3.1. That's the gig 00 on the app server to the switch. Then you got the IP protocol number. 17 is UDP, that's DNS. Then the 6 is TCP, and that's for 80 and 443. 17 UDP, that's for DNS again. 89 is for OSPF. The only thing is ICMP is not there. So what I can do is and there's ICMP at the bottom. So it had already been exported. So 192.168.3.1, that's apps gig 00, and the switch is 192.168.1.1, and protocol number 1 is ICMP. So the last command I want to do is show control plane hosts open ports. This command will list all the listening ports on the app server. So I've got TCP and UDP here for the protocol. Then the actual number 22, 23, 53, 80, 443, and 123. The services SSH, Telnet, DNS, HTTP, and NTP, and UDP transport server. And that concludes the lab.